just realized something that I need to note down. Okay. All right. What's up, Hacksters? It is 8 p.m. on a Wednesday, and if you can believe it, this is the first time I've had a chance, like a minute of downtime, to solder together this Charmware system that I got, that I created with the help of a friend who does PCB design, and with the help of Oshpark, who fabricated these. I completely designed them, and my friend Turner helped me turn that into a PCB. Yeah. Anyway, this is a modular tech jewelry system. So these were originally called PC beads, which is why they say PC beads V1 on them. And basically, this guy can hold a 1206 package surface mount LED or a resistor or whatever. These two holes here can hold a through-hole resistor. I think there's some around here, actually. Should have found that. Oh, here we go. Yeah, cool. We got some 10 ohm resistors here, just to demonstrate. And it can also hold something across its long axis as well. And the way you solder them to the wires is that you put the wires through here and then cross them over and solder them there so that you get strain relief. I haven't had a chance to demo them for anyone yet, though, so or even try them on by myself. So let's see how this goes. That looks pretty good. We used, standard resistor footprints and stuff. Oh, it's so pretty with that blue on there. Oh my goodness. I'm gonna flip out a lot on this broadcast. Let's actually make some of these with like a bigger resistor. Oh my. Break out my binder of resistors here. If you're curious about this, by the way, I recommend that you check out bit.ly/charmware, and you will be taken to the Hackster tutorial where I'll be putting all of this information, as well as the files that you can use to make your own. And I want more people to make their own like modules of Charmware as well, so that I get to use them, which would be fantastic. Let's use 120 ohm because I don't have a straight up 100, which makes no sense. Okay. So yeah, I'm just gonna solder one of these with a through-hole resistor to start with, I guess, because I've got them right here. Now I do. And then I'm gonna go through soldering the surface mount ones as well, because they're designed with a large enough package that you can use flat mounted surface mount resistors, so it'll be like low profile, but at the same time, they're large enough to solder by hand for people who are still pretty new to surface mount. So let's do this. Speaking of soldering things in our office, I had a soldering session earlier with Anouk Viprecht, the robotic fashion designer. She may be a robot. The fashion is definitely robotic. So I don't know. Yeah, that will be coming out on Saturday, aka Catterday. See if you can figure out what that means. It's not that hard. But really excited to bring that out during Maker Faire. Okay, so here we have the first one ever soldered. So the idea is that you string these in a row, in a loop, actually, a closed loop. This is how I think of circuits. When I diagram them, they have these flowy lines leading from component to component, rather than being all squared off and stuff. I've said this before, I'll say it again. But yeah, oh wow, that's really aesthetically pleasing. That's part of the point of this. And yeah, okay, so here we have a 120 ohm resistor. I'll just put that down here and we can watch the collection grow. I also have some that take battery holders, so for coin cells. And this is called a Dyson. It powers the whole circuit, named after the Dyson sphere in sci-fi. This one is called a star for obvious reasons. It can hold LEDs and more. So I have some through-hole battery holders, and I'm hoping that I can get some surface mount ones to mount to these too, because this is pretty high profile. I'm really not happy with the size of this. It does make it very friendly for people who are just like trying to assemble something, but I want something aesthetically pleasing as well, and to me this is too big and clunky. So I've ordered actually the next round of these PCBs in half height. So this is a regular thickness PCB, and Oshpark will do you a 0.8 millimeter one. It costs the same amount of money. It's no extra for this fancy half thickness PCB, but it does take longer because they don't fill up an entire panel of them every day because they're not as in demand. So you gotta wait a little bit longer, but it's the same price. All right, and then once I've done a few of these, I'm gonna attach them together into a circuit. That's pretty painless. Needs a little bit more solder. So I've got a resistor and a battery. Let's do some surface mount stuff. I'm gonna do some blue LEDs which don't need a resistor because they already suck down about 3 volts on their own. And then I'm gonna do some other colors of LEDs and some resistors. Now I've realized that I need a couple of modifications to this. One is that a resistor is non-polar. It doesn't care which way you put it. But an LED does. It is polar. And so it would be good to have some way to mark which way it goes. And for now I can just use which way the label is. Like maybe, you know, if you flip it like that, like a coin, you know? If you flip a coin over, typically it'll be right side up this way and right side up this way, rather than right side up this way and that way. But that's not very clear, so I think I will need to put some other kind of marking. Plus, obviously, I've changed the name from PC Beads to Charmware. All right, PC Beads kind of makes sense if you're going for a tech audience, but Charmware is a lot more self-explanatory for someone who's used to like working with beads and charms, and it also kind of evokes this magical feeling. Where are my tweezers? Here we go. I'm stuck on the thing. There we go. Okay, cool. So we've got these little LEDs. I think typically the ground side is marked with a little green dot. Come open here. They come in this little strip here. And I'll be updating the bill of materials and stuff on the project as well. Oh wait, are these reverse mountable ones? I think these are meant, actually, I ordered ones that have this little sort of dome thing on them, which can be, you can mount them upside down and then that little dome thing sort of sits in a hole on the PCB, and that way it can be mounted really easily, or it can shine through the PCB, but doesn't matter, it'll work anyway. So let's see, which side of this is ground? They are both green! There's a little dot on one side. I'll just try and be consistent, I guess. Okay, so here's PC beads. Here's that. And I will see if the little... Oh, this is really confusing. Yeah, this is why we prototype. Ah. Okay, and on the other side. The other thing about this is that it is split in half by a ground plane and a power plane. So that will make it ideally pretty easy for people to modify the design and make their own, because all they gotta do is plop a footprint down on top of it, and your PCB design software should take care of the rest. Well, it's not the most elegant thing I've ever soldered, but it just looks like it will work. Close enough for now. Alright. Let's do another one of those. I also need to be able... I should put a spot on here where you can mark what it is, because having a universal PCB is great, but some recent PCBs that people have come out with, they will put a space for you to put your name or whatever. so that you can, it's just like a little bit of white silk screen on there to make it easy. And so I could probably do the same thing for just marking what component each one it is. Oh boy, I don't remember how I did the last one. Yeah, this is definitely going to be a concern. It's an item on the list for sure. Come on. Surface mount soldering with a soldering iron is never like the best way to do it. You're going to end up with a lot of sort of non-flat objects. But as long as, like, that should be pretty negligible. And as long as it makes a solid connection, I'm not really worried about people looking super closely at it. That's number 2. And let's do 3 of those, just cause, well, maybe I'll, yeah, no, the package is open, so I should do more. Okay. I'm just snapping the little snappy bits off of here. So it turns out that if you order a medium run of Oshpark PCBs, you will get them fully routed, the outline, so you won't have these little bits that I'm snapping off as I go. Tweezers. Next I'm going to do a couple green LEDs and a couple of surface mount resistors, and then we're going to see if it works. I mean, it should work. It's just like, you know, physical electronic connections, but who knows? Trying to get this a little flatter in a pretty janky sort of way. Close enough. Yeah, that needs work. It would help if I didn't tin the pads first. Like, that's what's happening, is that they get sat on these little domes of solder, and that's why it's coming out all tilty like this, but I'm just gonna stick with this method from now because it's pretty much working. Part of the reason I'm making these, in fact, is to like learn the process, right? Going through the whole process of like prototyping this stuff, and ideally, if you're designing your own PCBs, you'll see the mistakes that I make and learn from them for your own projects. Okay, you go back in the static bag, anti-static bag, not a bag full of static. We got some resistors here. What I could do is put a little dab of glue to hold the resistor in place underneath it, and then just solder the ends in place, but maybe I'll do that, in fact. Where are my clippers? Here we go. You can also just like clip these off instead of snapping them on the table like I'm doing. Or break them. Whatever works. Whatever's clever. Okay. Couple of surface mount resistors. Maybe I will. Let me see how glue stick does with this. I was supposed to pick up some super glue, but I forgot. So we have, oh, that is several years old. Let's see what happens if I try to use it. I think we picked this up for like an old, that might just completely obscure the solder pads. I have no idea. We'll find out. Yeah, we had an old 3D printer that sometimes needed glue stick on the bed, although I've never really been a fan of that method of getting prints to stick. I think usually it comes more down to other factors in your 3D printing process, like, you know, if your bed is heated, if you've used a raft or a skirt, etc. So these are 100 ohms as well. 1% tolerance. Cool! Okay. What happens if I just kind of hold it in place and like tack solder one side of it? I'm gonna try that. Just like put you in place there. Ugh. Probably gonna end up with tombstoning. That's what's gonna happen. But we'll see. Well, I'm pretty okay. Got this huge glob now. But it's not so bad. can neaten that up as I go. Alright, that seems like a decent strategy. I think the glue stick was a mistake, but otherwise we're good. Okay, oh yeah, besides denoting which side is which, like I could just have a default marking that shows like a plus and a minus and you don't have to have it, you know, if you use a resistor or whatever. Besides that, it would be nice to be able to mark like what value of resistor it is. In this case, it's pretty easy because it says 1000 on it, which means 100 ohms and 0 extra zeros. But it's sort of like a brown, black, black, black striped resistor if you were doing a through-hole one. But, yeah, this isn't too bad. Anyway, yeah, but for like LEDs and stuff, it'd be nice to be able to mark what color it was. Move it around this with the solder a little bit. There we go. Do that, and then clean up that one. Okay. Cool, that's 2 resistors. Now let's do some green LEDs, yeah. And then I'm going to be done with the soldering, and I'm going to start actually trying to put this together into a circuit. Moment of truth. Yeah, the half-height PCBs are going to be a lot classier, too. I'm excited for that. Oh yeah, actually I have some other components. Let's do a red resistor, or LED, or green. Here we go, green water clear LEDs. And I happen to have also a button, a reed switch, and then I've got a battery that will help connect the reed switch, or not a magnet. Did I mention it's 8 p.m. and I'm in the office? But I can take this little magnet out of here and string it onto my necklace in a different spot, and then when I bring them together, it'll close the reed switch magically! And I also have a haptic vibration motor here. So let's see. We are doing green LEDs for now, though. Let's do 2 of those. And this is also for my own practice. This one has a little arrow on the bottom. They've all got different markings. This one does seem to have the little green dot. If you can see. On the top right corner of it there, you can kind of see the little green dot. Cool. Gonna hold it in place with— oh no! That didn't work. That totally backfired. Try this one more time. You already need to have a little adhesion if you're gonna try that trick. Okay. Okay. We're gonna put a little blob down. Then we're gonna use this to push it around. Oh god! Oh my. This is going okay so far. So this is definitely not a beginner's sort of board yet. Obviously. I have a lot of experience with soldering and I'm actually kind of struggling with this. So, you know, notes to self. Da-da-da, da-da-da. Like that. And then we have the LED. It has its little arrow pointing. I'm going to point it the other way. This is going to be so hard to like determine later on. Well, these ones will be easier because they've got the little dot on them. Any LEDs where I have the little dot indicator on it are going to be a lot easier. So maybe that's the takeaway here, is that I should just use LEDs that have like a very clear indication on the top. Now the other thing is that you can't always trust the images in an online component retailer. Hey, that worked pretty well. Look at that one. That looks nice. Look, it looks nice. Cool. Sweet, little LED. Yeah, and I can tell that these blue ones are the domed ones, and these green ones are the flat ones. Okay, now for some other components real quick. I got a ton of these stars, so this is great. I think I want to try, actually, one weird thing, which is this one weird trick, using circuit stickers from Chibitronics. I think I should be able to sort of put them across like this. Maybe I can't. That could be a lie. But maybe. They seem to have like a little insulating spot in between, and I'm kind of afraid. The glue, I think, is conductive, but not too much because these are connected, like there's glue all the way across, so it can't be that conductive. So maybe if I just kind of lay this across the boundary. Oh, boy. It might work. It might not. We'll find out. This is a little stick-on LED with built-in resistors that is white-colored from Chibitronics circuit stickers. They are made for putting on paper. But you can put them on whatever. We'll see if it works. It's designed by Bunny Huang and Jie Qi. Okay, now for the other components. Yeah, so these should be much easier. We've got a reed switch, which is going to be a little weird. I'm going to put that in the same slots that I use for the wires, and I think it'll come out just fine, but we will... Ooh, oh, the glass is cracked. Gotta be careful with this. Reed switches. So delicate. Okay, let's see. Because I do need to bend it rather severely, so I'm just going to hold right next to the component while I bend it in. Let's see, is that big enough? Yeah, okay, cool, good. Now bend it out to hold it in place. Solder on the other side. A little more. Making sure I'm heating both the leg and the pad when I'm soldering, as always. Ooh. You know, some people say you should always be wearing safety goggles when you solder. That's probably true. I don't. I do, however, keep a hold of the little legs when I'm trimming them off, so those at least will not fly into my eyes. Okay, here we have a reed switch. I'm really curious to see if this one will work, because I want it to a lot. Because I think the magnet plus reed switch interaction is just really magical on its own, and then if you combine it with other things like beads, then it will become extra cool. Okay, two more, button and a haptics feedback motor. This button is designed for to work with the SparkFun LilyPad system, and this should be well insulated by the solder mask in the middle. So I think if I solder it across like this, it will work. I'm basically just trying to test the versatility of the system with a bunch of different things I have on hand. So there are a bunch of ways people are trying to make technology more sewable and make it interact with paper and Lego and all this other stuff. And so I want to make it work that way with jewelry. Okay. Seems to be working all right. It's not going to sit flat, I think, but I should at least be able to get sort of a connection going. And if I heat both sides at the same time, it's going to get a little toasty, but maybe I can get it to lay flatter. That seems to be about as good as it's going to get. Ooh, definitely toasty. Ooh! Most of the actual injuries that I sustain from this are from just handling stuff while it's still hot. Why did the hipster burn herself soldering? Because she touched her PCBs before they were cool. I'm sorry. I'm not sorry. Where is my haptic motor? Here we are. It's so tiny. Okay, last thing. I'm going to trim these leads really short. And then I also have a hot glue gun here, which I'm going to use to attach it, because I don't want it just like flopping around all over the place. That would be suboptimal. But I am going to stick it in the, let's see, how do I want to do this? Yeah, stick it like that. Like that. Okay. Oh, I had a system. PCBs like that. I was putting the ground side over there, I think. So there's also a whole decision about, like, you know, which side I want to have the label on versus the components, you know. Right now they are on opposite sides, but only because, like, that's where I've got the little surface mount guy. I could just as easily put the through-hole ones on the other side of the PCB. Okay. That should hold okay. I have to hold on to this while I solder it, though. Oh no, it's already coming out. Oi! These little tiny wires are pretty annoying to work with. But okay. Like this. Ground goes on the left. All right. Again, I'm going to put myself through a little bit of discomfort here in order to get a solid first connection. But what I can do is sort of put this solder like this. I've just bent it so it rests on the table, and that'll help me get a quick, good connection. If I angled it differently, it would anyway. Whoop. Stop wiggling there. Ooh. Okay. Now I'm just trying to make sure that both the wire and the solder pad are getting well connected. Cool. Oh, ow. That's what I get. Okay. Some things are not meant to be done with your fingers. Oh, that's already coming out. Let's push that down. Okay, that looks pretty good. Now, when I add more hot glue, I should be able to melt the stuff that's already on there, just using the tip of this. Yep, okay, cool. Oh! It's not going in. Here we are. Okay. So now this one should work as a haptic feedback motor. Some of these also work as work with the SparkFun LilyPad kit. So it comes with a little haptic feedback motor module actually, and it's made to be sewable, so it has little holes in it. But I wanted bigger holes because I want to also be able to put this twine through it, and I'll be knotting that to create a sort of stable network that, or necklace that, like, supports the things that I put through it. Okay, so we have 3 blue LEDs. We have a haptic feedback motor. We have a couple of 100 ohm resistors, surface mount, where's my other one? Here we go, and through hole. 120 ohm anyway. We have a button. We have a white LED from Circuit Stickers. We have a Dyson battery module. And we have a reed switch. And then a couple of green LEDs. That's not bad. Cool. So I'm going to see if I can actually string these together into a circuit. I'm going to start with, you know, I'm going to go with actually multicolored wires, which is not super classy, but they happen to be right here and already cut up, so I'm going to do it. And hopefully the end product will be long enough that I can sort of wear it as a necklace. We've got more little wires over here. Oh, you know what? I don't know if I can do that aesthetically. Let's see. Do we have... What colors have we got over here? We've got white. White kind of works with the color scheme. I want to be really flexible, though. This is actually more flexible than that little stuff. Is it? No, the little stuff is more flexible. All the considerations. Okay. I'm going to stick with these colors for now and see if I can make a whole circuit that way. Okay, so the whole idea here is, let's grab a green LED, a resistor, a battery module, and just start with that. In fact, let's start with a blue LED and a coin cell just so that we can get the feel for this, and I'll start building up more complex things later on. Okay. So, again, I haven't done this before, so it may take a second to learn, but as I'm the inventor, I should have a pretty easy time of it. Otherwise, there's probably something wrong. So basically, I'm going to bring this through here and solder it through there. And that will give me a little bit of strain relief from yanking on it, because the thing with both wearables and jewelry is that they go through a lot of stress just from being part of a strand of something and being flexed and stuff. So this basically takes that stress off of the solder joint and puts it into this other hole. Okay, now let's do the same with this. Ooh! Maybe I'll solder the first one first so that I don't lose that. Ah! But I can use my alligator clip to hold that in place. Okay. All right. And now the other one. Can I just do that from the other side? Is that possible? I gotta twist it up so that it all goes through the hole nicely. All right. No, I think I gotta flip it over and do this. Okay. Got a slight impression from the jaws of death there. There we go. Okay. Stick it into the thingy. And solder. Ideally, it should be pretty simple once you've assembled a circuit. You could also like put it through and solder it through these holes as well, but for consistency's sake, this is what I'm doing. And I think it looks cool with those sort of slashes and then the LED going the other way. So cool. What was I saying? Don't remember. That's fine. So I'm just going to make a little short strand to kind of test this. It's not actually going to be wearable, really. Oh, here's another magnet. This one's much stronger. Just random magnets in the office. Not surprising. I think it helps to have these ends a little bit longer to help hold them in place when I'm soldering. Okay. Now the LED has a little green dot. Oh no, the green dot is invisible. Oh, this is a blue one, right? Well, what I can do is actually, if I stick a coin cell in here, it will soon become apparent. which way it goes. Okay. Positive side goes up. The outer casing is contacting this side, so that means this is the positive side and that's the negative side. Okay. Positive, negative, positive. Okay. Oh, I could use this direction of labeling as an indicator. Okay, so positive, yeah. Oh, you know what? I shouldn't actually solder to this with the battery in, but I'm just going to test it for now. So positive is up. All right, now I can just test which way it goes. Let's see. Not that way. Or I've done something horribly wrong. Also not that way. That's not great. Oh boy. I wonder if these... Oh, wait, no! We have liftoff! Oh, this is so cool! Oh, sweet! Okay, so it goes like that. Then, basically the next thing I'm going to do... Let me double check. That way? Yeah, okay. Is stick these through here and just solder them directly onto there. And I could do a little hook around if I wanted. In fact, I think I will. Oh, hi, earring. You're along for the ride, huh? I was using these magnet beads on these earrings to hold pins while I was sewing some stuff during eTextile spring break, which was awesome! Okay, let's get this curled around a little bit. Then I can kind of hook it on. Get some more solder on there. Ah! Okay. So this is the basic idea, you know, you have a loop, you connect your components all in a loop. I am going to do a transistor, and that might seem a little confusing to you right now, but I promise it will clear up once I get it working. That one is going to be called a satellite because it amplifies signals. Among other things, like you can use transistors for all kinds of stuff, but in this case, I think I'm going to be using it to amplify, for example, piezo discs being used as sensors and stuff like that. So, and then you'll just have a sort of branching circuit structure. Oh yeah, right, I was supposed to take the battery out before I soldered. Ha! Well, not dead yet. It is working. That's pretty great. I'm not dead yet is a terrible reason to not take safety precautions, just for the record. I don't advocate this approach, but what's done is done. It's late. That's also a terrible reason to not take safety precautions. But yeah, okay, so it's working. That's awesome. The next step would be to put a switch in this circuit, and that would be my little reed switch, or my button. And yeah, or a sensor or whatever. And obviously to make it a bit longer, because this is really short, and I would want to have a longer like bracelet or necklace or whatever. You can align them kind of however you want. The idea is that they'll sort of resist the force from twisting or whatever. And yeah, cool. So you can make strands of whatever, attach them to your clothing, put them on your epaulettes. I do plan to make epaulettes. That's going to be awesome. And yeah, I'm just really excited that this works. Thanks for watching this demo. I hope that you eventually order some charmware and start making your own. Thanks for watching. Ciao.